All right, so we left off last time with the law of sines. This is just a reminder of what the law of sines is. It's a set of three fractions, and we usually end up setting a portion up where we cross multiply to solve. If you're solving for a side, it's pretty much just cross multiplying and isolating the variable. If you're solving for an angle, you still have to cross multiply, but it's going to involve inverse trig because you're trying to get rid of the trig function. Okay, but that's only when you're solving for an angle. So there were three types of triangles that we could use law of sines for. If you know two angles and a side that's not between the angles. If you know two angles and a side that is between the angles. Or if you know two sides and the angle not between the sides. Those are the three types. This is the type that we're going to focus on today because that's the one where you could end up with one solution to the problem like we did last time, two solutions, or no solutions. These two types of problems always just have one solution. When I say one solution, I mean one solution for the three things you're trying to find. Okay, so in this case, one solution for the second side, one solution for the third side, one solution for the third angle. But in this last case, you could end up with 0, 1, or 2 solutions for the third side, and 0, 1, or 2 solutions for the second angle and the third angle. And that's what we'll go through right now. So there's really no other explanation other than just make sure we remember the formula. All angles have to add up to 180. And Pythagorean theorem is not something we can use unless we know one of the angles is 90. But most of the time, the angles in this section are not 90, because if they were, you wouldn't need to use law of sines anyway. You could go back to Socrates. Okay, so first thing we want to do is figure out if this is a problem we use law of sines for. Now, one way to do it is make your sketch. And if I put A on the bottom, where does alpha have to go? It's got to go across, right? So that means it's up here. And if I put B over here, where is beta? Across from it, right? All the way on the bottom, right? And that would make this side C and gamma. So I can tell it's law of sines by looking at it. It's side, side, and an angle that is not between the sides. That's the third type. But besides drawing a sketch, there's another way I can tell it's law of sines. Does anybody remember when you look at the table, what gives it away in the table that it's law of sines?
Wait, sorry, how can that not be law of sines?
We're going to do that next.
Okay.
Today, I think we are. Yeah.
Is it that there's one complete row of information?
Yeah, there's one complete row of information, and that's how we could tell it's law of sines. And there's also a row that's completely empty. That's how we can tell that it's the worst case for law of sines, because this row is completely empty, and you have no way to find anything in this row directly. You have to find something else first. So what do we have to find first? Yeah, we have to do beta, because when you do law of sines, you need a full row and a partial row. That's how you solve it. Question? No? Okay. Sorry. I thought you had a question. You look slightly confused. Probably just me coming back from it. Maybe you too. So we're going to try solving for beta first. Okay, so let's find beta. And we're going to set up a fraction. Can somebody tell me what I could put on the left side?
The sine of 35 degrees.
Yep.
It's not over 6.
Yep. Sine 35 over 6. And what about on the right side?
Sine beta over 8.
Sine beta over 8. So this is the type where we're going to have to use inverse sine at some point to get the variable alone. I don't even need to cross multiply. To get sine beta by itself, we just need to do what on both sides?
Multiply by 8.
Just multiply by 8. So times 8. Just going to put times 8. So we have 8 sine 35 over 6 equals the sine of beta, but our goal is just beta, so how do we get rid of sine?
Inverse.
So we take inverse sine of what's on the left. I know that I could reduce 8 over 6 to 4/3. I mean, it doesn't really matter. So we're going to take the inverse sine of what's on the left and what's on the right. Now, at this point, we're either going to get an answer on the calculator or we're not. If we don't get an answer, then you either made a mistake or it is a no solution problem. If we get an answer, then we need to write it down and then we have to check for the second. All right, so let's first of all make sure you are in degrees. Type in second inverse sine of 8 sine 35. Close your parenthesis because you're done with the 35. Close it again because now you're done with inverse sine. Okay. So this is not a no solution problem. I just got a solution. 49.886.
Hey, why are you taking the inverse sign of that? I thought it was just.
Because I have to cancel out sine.
Yeah, then. Oh, it's still. You still have. Never mind.
So we got 49.886. I want to put that up higher in the box. Because if there's a second answer, I'll change this to beta 1 and I'll call the second answer beta 2. Now, we're dealing with angles. Well, we're dealing with inverse sine. Think about sine. What two quadrants is sine posited in?
Oh, the top two, right?
Top two. You just got an answer in quadrant 1. How would you get the answer in quadrant 2 using 49.886? What's the formula in quadrant 2?
180 minus. Right.
Yep, 180 minus 49.886. So if there's a second answer to this problem, that's what it would be. Now we can't write that down yet. 130.114. What do we have to check with that potential second answer? Got to make sure
It's still a triangle, right?
we got to make sure that it would still be a triangle, which basically means that that angle would fit. What do we have to check it against to see if it would fit? The angle we already have. This angle is given. This angle is in the triangle no matter what. Can you fit 35 and 130 in the same triangle?
Yes.
Yeah.
Yes, you can. That only adds up to 165.114. So that means this second answer is small enough that it works. Now we need to write it down. So at this point, we're now going to split this into two problems. I'm going to use the same table, but I'm going to show you how we split it. If we know that beta has two answers, then that automatically means at this point, everything we are solving for has two answers. Not what we were given. Don't worry about what was given. That's fine. It's just what is in the boxes. So gamma is going to have two answers, and C is going to have two answers. And if you wanted to kind of color code it so you can see, well, what's actually happening here, we could think of like one problem we're doing is the black triangle, and the other problem is the red triangle. The black triangle has these three angles in it. Alpha, beta 1, gamma 1. Those are the three angles in the black triangle. The three angles in the red triangle are alpha, beta 2, and gamma 2. So alpha is what we call a shared angle. That's in both. It's in the first problem we're doing, and it's in the second problem. As far as sides, we could do the same thing. A is in the first problem, B is part of the first problem, and C1 is part of the first problem. A is also part of the second problem, B is part of the second problem, and C2 is part of the second problem. So you should see 6 black dots and 6 red dots up there. Each triangle has 3 sides and 3 angles for a total of 6 pieces of information, and some of the information is shared in both triangles. If it's confusing to do it all in one table, you could do 2 different tables too. You could set it up. But I find it simpler to just keep it all in one. So any questions on how we got beta 1 or how we got beta 2 and know that it is an answer to the problem? Okay, so now this is what we call a 2-solution case. Let's get gamma 1. What angles am I going to add together and subtract from 180 to get gamma 1? Yep, alpha and beta 1. So we're going to take 180 and we're going to subtract the 35 plus the 49.886. So that gives me 95.114. Okay, and you could do C1 right now because now you have a piece of information in the last row, but I like to just finish off the angles first. Okay, how are we going to get gamma 2?
So 180 minus 35 and 130.
And what's 35 plus 130?
165.
Okay, so 180 minus 165.114, which means gamma 2 is 14.886. Yes.
Can you remind me why the beta 1 and 2 add 180 but the gammas don't?
Why beta 2 and beta 1 add to 180? That has to do with the formula in quadrant 2. Because in quadrant 2, you do 180 minus your reference angle. So to get that answer, you subtracted that from 180. That's why they add to 180. Yeah. Okay, now let's do C1. So you're going to set up a proportion, and C1 is part of the black triangle. So we need a row. We need like a black row in the table that has everything in it. How many rows in the table from the black triangle are full?
2. All of the first 2.
The first 2, A and alpha, that's part of the black problem. So is B and beta 1. We could pick either row to put on the left-hand side.
Should we use what's given to us for what's transparent?
Yeah, we should use what's given, right? So we're going to do sine 35 over 6, just like we started out with. And now we're solving for C1. So what angle in this box am I going to use to get C1? Gamma 1. And what angle am I going to use to get C2? Gamma 2. So we're going to do sine 95.114 over C1. And let me set it up for C2. C2 is part of the red triangle. But again, just go back to the row that was given because we know that it's right. Sine 35 over 6. Equals. And what's going to go on the other side to set up my proportion for C2?
Sine 14.886 over C2.
Yep. Sine 14.886 over C2. So now cross multiply we'll have our answers. So C1 is going to be 6 sine 95.114 divided by sine 35. So there's your answer for C1, 10.419. And C2, it's pretty much the same calculation, except we're going to do 6 sine 14.886. 14.886, but still dividing by sine 35. 2.687. So that's a two-solution case with law of sines. 6 different answers there, and you get partial credit for every answer you get. Any question on that? So the one solution case we practiced before break. This is the two solution case where you've got 6 different things you have to solve for. 2, 2, and 2. And what I can do quickly is show you visually, this isn't really something you can write down easy, but I can show you visually how the two solution case could happen. So I'm going to draw perfectly to scale 2 sides and an angle, 2 triangles that each have 2 sides and an angle in common. I'm going to start with that. Let's take and go like that. Does everyone agree that that and that are the same?
Yep.
Now, let's take this side. I'm going to make a copy of it, but I'm going to mirror image it. By reflecting it, is this side still the same as that side?
Yes.
Yeah. And now I'm just going to draw my third side on the bottom. And does everyone agree that that bottom side is the same as that bottom side?
No.
Okay, good. I don't want you to agree with that. But I want you to agree, hopefully, with something else. That this angle in the lower left is exactly the same in both.
Yes.
Yeah, that is the same. So I just drew 2 different sides, 2 different triangles that have exactly 2 sides the same length and 1 angle the same measure. The angle is not between the sides. And that's an example of the type of problem we just solved. All the information with tick marks is what was given. So that would have been like my A, B, and alpha. And then anything that's not marked in the triangle, that, and that would have been the information that you solved for. And you could get 2 different answers for that angle, 2 different answers for that angle, and 2 different lengths for the bottom side. But that's visually how the two solution case happens. Okay, so let's take a look at this. Okay. Again, if you know what you're looking for in the table, you really don't need a diagram. How can I tell whether this is law of sines or not, just from the table?
There's the complete row and the
Yep. There's a complete row. So I definitely know it's law of sines. There's also an empty row with no way to find anything in it. That tells me that it's the worst case for law of sines, the case that I have to check for the no solution or 2 solution. Okay. So based on what you're given, what do you have to find first? Alpha. You don't have any choice. You've got to do alpha first. So let's find alpha. And what's going to be my proportion that I set up to find alpha? Sine 50 over 1. Okay.
And then sine over 2.
Sine alpha over 2. I don't even really need to cross multiply here because I just multiply each side by 2. and you get 2 sine 50 equals sine alpha.
Sorry, just what were the values of them? Oh, okay, just
And what would I do next to get alpha by itself on the right? Yep, take the inverse sine. Now, when you fill something, well, I won't put it there actually. Put it here. When you fill in something to the inverse sine function, okay, what you plug in, that's called your domain. Does anybody remember what the restriction is on the domain? When you plug something into inverse sine, what does it have to be between?
-1 and 1.
It has to be between -1 and 1. So if you just check out what's happening inside the parentheses. 2 sine 50. It's 1.5. So if I try to take the inverse sine of 2 sine 50, bless you, what's going to happen? Yeah, it's going to give me an error. It's going to give me a domain error because you're trying to take the inverse sine of something that's bigger than 1. So what do you think that means when you're trying to solve for alpha?
It's not a solution.
This number is not a solution?
No.
There what?
There's no solution.
There is no
There
solution.
can't be
Yeah.
a solution.
It's not possible to get a solution. Now at this step, we would normally take what we just got for alpha, add it to 50, and subtract it from 180.
But you can't.
But we can't. So what does that mean about beta?
There is also no
Yeah, there's no solution. And if you can't find the angle,
You can't find the side.
you can't find the side because you need at least one piece of information in the row, and we don't have that. So the whole problem is no solution. So either everything has 2 answers, everything is no solution, or everything is one solution. That's what we did before. And if you're wondering how would this work out to no solution, I'm not going to draw it, but if you actually do sketch it with like a protractor and measure things out, the sides don't connect. This side is too short or this angle is too big, but you basically end up with something like this. You can't make a triangle out of that because this would be like your 50. So you might say, well, yeah, just make this angle smaller so the side meets. You can't. And then you might say, well, what if you just make this side longer? Well, you can't make that side longer because that's the side that was given. This bottom side and this side is also the side that was given. So you can't change the length of these 2 sides, side, side. You can't change that angle. The only thing you could do is you can lengthen and shorten this side because that wasn't given, but that's not going to help. And this angle was not given. This is the 50. So you could rotate that little side like that, but again, no matter how you rotate it, you can't make it connect. That's what ends up happening. So that's a no solution. Any question on that? All right, let's try a word problem. I have 2. I think I'm going to do 1. Probably do 1 with you guys, and I'll do maybe a different one in the next class, so that way you can see one of each. If I do a different one in the video, I think that'll work. All right, so to measure the height of a mountain, basically what's going to happen is a surveyor is going to take 2 measurements. So the idea is you stand in one spot, you take a measurement, you back up a known amount, so you have to know how much you back up, and then you measure again. And using those 2 measurements, you can find the height of something that's in the distance. The key is when you measure each time, you have to know how far apart your measurements are. And what you're going to measure each time is what's called an angle of elevation. Imagine if you were pointing like from the ground, a laser at the top of what you're measuring. The closer you get to what you're measuring, the steeper the laser would point. The further away back you move from what you're measuring, the less steep it would be. So like if I stand like right under the light, my angle of elevation from the floor, it's very steep because I'm right under it. As I start to back away from the light, I don't have to look up quite as steep to be looking at the light because I'm further back. And that's what is going to be measured each time. So the first observation gives an angle of elevation of 47 degrees. And then when he backs up 900 meters, we would expect the angle to go down a little bit. And it does. It's 35 degrees. So you could probably condense that. I mean, you could just say, 900 meters, angle 1 equals 47 degrees, angle 2 is 35 degrees. And the device that you could use to do something like this is called a transit. Now, technically, the transit is on a tripod. So you're not really measuring the angle of elevation from the ground. You'd be measuring it from like maybe a 5-foot tripod up. Well, we're going to pretend that the transit was on the ground, that it wasn't on a tripod. Because it's just one less thing you have to take into account. But if you did it and you wanted to take into account the tripod, all you'd have to do at the end of your problem is add in the height of the tripod, plus 5. It's not really a big deal. But we're going to assume it's level with the ground. Okay, a lot of information there. So, what do you think would make this problem easier to think about rather than having it written in like a sentence form? Yeah?
Make the same table that we made. Or like make a triangle. Oh no, we can't do that.
I want to think even more general, like more of a general strategy. Nothing.
Like just write down what we know.
Do what?
Highlight and hurt.
All right, you can highlight some stuff, and then still you got to do something with all the information here. I think to make it easier to think about. Like, you got to represent this all a different way. This whole situation.
Could you do it visually?
Yeah, I would draw some type of diagram. Don't worry about drawing a triangle. Worry about drawing the diagram, and then when you put the objects in the diagram, triangles are going to happen automatically. So what's something that's really important if we're going to be drawing a triangle, or drawing a diagram? And I'm thinking just basically objects I need in my diagram.
Transit?
So we're going to pretend like the transit's on the ground, so we don't have to factor in the height of the transit. Yeah?
Mountain.
We need a mountain, and even more basic than a mountain, we need the what?
You need person.
Okay, we'll just, represent them as like a little dot or something, but yeah, we're going to have to mark 2 spots where a person stands. And the mountain, and
The peak of the mountain.
the peak of the mountain, yeah, that'll be part of the mountain.
The ground though.
The ground, yeah, we got to put in the ground. So start by drawing a horizontal line that represents the ground. There's the ground. Let's put our mountain over there. So there's our mountain. And the surveyor measures the height of it from 2 different spots. We don't know how far those spots are from the mountain. That's the whole point. You don't need to know how far you are from the mountain at all. But you do need to know how far apart your 2 measurements are. And what did the problem say for that? 900 meters. Now, remember, let's write down what the goal is. The goal here is we're trying to measure the height of the mountain, in case I didn't spell that out. I didn't really ask at the end of the question. I didn't really ask. But the goal is to find the height of the mountain. So remember, the height of the mountain is this. That's the height of the mountain. Not the side you would like hike up. That's like the slant height. We want the height. So there's your height. And we're going to measure 2 different sightings to the peak. So imagine like pointing a laser from where that guy's standing right at the peak. Basically, we do something like this. 1, 2. The angle of elevation is the angle that the laser is pointed at, so it points right at the peak. What did it say the angle was the first time? 47? And then what's the angle the second time?
35.
35. Okay, so now we've got a couple triangles. Ideally, if we could just take this triangle that's in green and solve it for the height, we'd be done. Well, we know that that's 90. We know that's 47. Do I have enough information to solve for the height? What do I need at least one of? Got to have a side. I don't have a side. So we're going to have to come back to this triangle after we figure out something else. And H is what I want to solve for. All right. So then let's look at this other triangle right here. I'm looking at that triangle for two reasons. One, it shares a side with the green one, so that might be helpful. And I have more information, and I have a side length. Okay, so see how it shares that side. So we know this is 900. We know this is 35. How about this angle inside? How would we figure that out?
180 minus the angle given.
Yeah, it makes a straight angle, so 180 minus, what was it, 147?
Yes.
Yeah.
So it's going to be, what, 133?
Yes.
And now you have enough information to work with the red triangle. Angle, side, angle. That's a law of sines problem. Now, in order to use law of sines, you have to have a full row in the table. What that means is you know a side and you know the angle across from it. I do not know the side and the angle across from the red triangle with what is labeled. But is there something I can figure out?
Yeah, the top angle.
I can get this top angle. It's not the answer to the question, but I can't do the problem without it. I need this top angle. What's 133 plus 35?
Wait, sorry, how'd you put up there?
Subtracted 47 from 180.
It's 160.
So if you add these together, 133 and 35, that gives you 168, which means this angle is how much? 12. Now you know an angle and the side across from it. So we can set up law of sines. And let's solve. Let's call this side from here to here. Let's call it A. We're going to solve for A. What would be my proportion to solve for A?
Wait, alright, is it gonna be one of the homework like this?
There's a couple word. There are some word problems. Yeah, there will be. Yep.
Sine 12 over 900
Sine 12 over 900. Good.
equals sine of 35 over A.
Perfect. Again, you might be like, why are we finding A? Well, I kind of already showed you, but we'll talk about what A is. It's something in the red triangle, but we'll talk about it in a second. Okay, so A is 900 sine 35 over sine 12. So let's see what A is. So unfortunately, this is the kind of problem where you can't figure out what they want you to find directly. You have to find something else first. Then you can find what they want. Just some problems are like, not all.
It's multi-site.
Yeah, it's definitely a multi-step kind of problem. Okay, so A is 2,482.88. So 2482.88. Okay, great, that's A. Now, A is the side across from the 35 in the red triangle. But what is A in the green triangle? It's the hypotenuse. So the whole reason we didn't work with the green triangle right away is because we didn't know any sides in it. Well, now we do. We know the hypotenuse of the green triangle is 2482.88. Now you have plenty of information to solve for the height. This is a right triangle, so you do not need law of sines to solve this right triangle. From the perspective of the 47, what position is side H in? That's opposite. And what position is the side across from the 90? That's your hypotenuse. And what trig function has opposite and hypotenuse in it?
Sine.
Yep. So the sine of 47 equals opposite over hypotenuse. And how would we get h by itself?
Multiply by the denominator there.
Yep, multiply each side by the denominator. And that is the height of the triangle, which is the height of the mountain. So 2482.88 sine 47. 1815.86. And I think that was all in meters. Yeah, that was meters. So, like any word problem, I can't really go through every type of problem you could have. But the idea is problems will always create a triangle. Another type of problem involves, I'm not going to go through this one, but it involves having like 2 Coast Guard stations. And they each can see like a light, maybe it's from a boat or something, out in the water. And the goal is to figure out where that boat is. We'll assume the boat's not moving because then that complicates it. The boat's not moving, and I want to figure out where it is. Well, as long as each Coast Guard station has a compass, each station can say, well, I can see the boat somewhere along this direction. And the other Coast Guard station says, well, I can see the boat somewhere along that direction. And as long as you know the distance between the 2 Coast Guard stations, you basically have just created a triangle where you can triangulate exactly where the boat is. But the goal is you need to know what direction the Coast Guard stations can see the boat in. And they would tell you that. Like I can see the Coast Guard station, at a compass heading of 40 degrees, or they tell you that in the problem. That's another kind of problem you could see. And the nice thing about this one is it is just one triangle. It's not 2. So you don't have to find something else before you can actually go after what they want. You can find what they want right away. Because usually you know this, that, and that. Angle, side angle.
Alright, what kind of problem is this from?
That's like a problem where you have 2 observers seeing the same object. Whether it's a boat or 2 fire towers in a forest seeing smoke from a fire.
Oh wait, wasn't this already a pretest?
I don't remember. It might have been. It is something that might come up on the final, so it could. I don't remember. I don't think it was, as the pretest usually covers everything from August to January. So yeah, this would have been beyond that material. Any questions on that word problem?
I'm going to do others like it today.
We might get to another. Actually, no, we won't get to another word problem today. There is another word problem tomorrow.
Okay, because I was very confused.
But we will, whatever the next class is, we do have another word problem. Yeah. Yeah, I think this next one I'm not going to do, but this is about the 2 Coast Guard stations telling the direction they see the boat in. But I think I'm going to hold off on that one. So the last law that we're going to look at is law of cosines. Can someone remind me again, what are the 3 types of problems we use law of sines for? Yep.
AAS.
So 2 angles and a side, where the side is not between the angles.
A and C.
Same information given, but the placement of the side is now in between. Yep.
And SSA.
And 2 sides and an angle where the angle is not between the 2 sides.
Wait, sorry, is it just 8 with 2 at this point?
So, well, there's only two other types left for law of cosines. What do you think would be the two types that you could solve with law of cosines? And you might be thinking of a third arrangement of the letters you can do, but that would be impossible for, well, if it comes up, I'll explain why. Does anyone think they know the other two? Yeah? Yep. Two sides and an angle, but the angle is between the sides. And there's one more, yeah? SSS. Okay, nobody said AAA, which is impossible to solve because if you don't know a side, you don't have any scale. Like if I told you I'm thinking of a triangle and all the angles are 60, 60, 60. You know it's equilateral, but you don't know if it's 2, 2, and 2 or 12, 12, and 12.
What's the LOC stand for?
Law of sines, law of cosines.
Oh,
So that's basically a table that summarizes when you can use which law. We've covered these three. This is the case that can have 0, 1, or 2 solutions. These cases will never have 2. That I can guarantee you. It isn't, in this case, we'll always have at least 1. Exactly. It is possible to end up with a no solution with side, side, side. Imagine I gave you sides of 1, 1, and 300. Do you think you could make a triangle?
No.
1, 1, and 300.
No.
Probably not.
That's basically what you'd have. So remember the rule about triangles. What's the rule with sides in a triangle?
The two smallest have to equal the biggest. Or bigger. Equal or bigger.
Can't be equal.
Has to be bigger.
Bigger.
Any two sides added together have to be bigger than the third. Any two sides. 1, 1, and 300, that doesn't work. 1 plus 1 is 2. That's not bigger than 300. Okay. Even 150, 150, and 300 wouldn't work. Because any two sides added together have to be bigger than the third, not equal. It has to be bigger. So it is possible to get a no solution with side, side, side. If you check what I just told you to check. 2 solutions, nope, never happens. So, law of cosines, I already basically summarized that for you. That's the 3 types we used. Law of cosines. There's the other 2 types. I've just drawn them out as diagrams so you could see them. Here's an example of side angle side. You know 2 sides and the angle that's between them. And you might say, well, why can't you just use law of sines? Well, what would happen is when you set up your table, what has to happen in the table?
You have to have 1 complete row.
You got to have a complete row. And if you knew these 2 sides and that angle in that arrangement,
That's not a complete.
it would look something like this. You would know 2 of the sides, 1 of the angles, but you'd have no way to get the 3rd side. You can't use Pythagorean theorem. And you can't get either of these 2 angles by subtracting from 180. So law of sines doesn't work. And side, 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 well, it's the same idea. If you know all 3 sides, then you don't know any of the angles, so you don't have any 4 rows. So what theorem can we use? I think I already said it, but if you knew you had a 90-degree angle and you wanted to figure out the sides.
That's good. No.
And what is that theorem?
A squared plus b squared.
Right, so a squared plus b squared equals c squared. Well, you can't use the Pythagorean theorem, but what you can do is you can adjust it a little bit and use it. So I'm going to show you kind of the adjustment that we make to the Pythagorean theorem to use it in this kind of situation. And that adjustment turns it into what we call the law of cosines. So apparently I didn't write down the law of cosines. So I'm going to write down what that law is right now. That's an important part of this lesson.
Yeah.
What did you say the Pythagorean theorem was?
A squared plus b squared equals c squared.
You know what, I'm going to write it the other way because it's just easier for me. So if we had a right triangle, we could use that formula. But we don't, so we need to make an adjustment. Now, normally I go through the proof of that adjustment. We're not going to go through the proof right now. All right, so that's the Pythagorean theorem. But if we subtract something on the end, it turns into what we call the law of cosines. The proof of it is actually not that hard. But it's not something that we're going to go through right now. And what we subtract is twice the product of the two sides that we had right there times the cosine of the angle across from C. Now, we can write this law, I guess depending on the letters you use, you could write it an infinite number of ways. A's, B's, C's, X, Y, Z's. But the general pattern is it's the sum of the other two sides that you didn't use the letter for here, minus twice the product of the two letters you put here, and then the cosine of the angle across from what you started with. So let's just see if we can write it, same pattern, just in the different letters. What do you think would be the two letters we add together here?
A and C.
So A squared
Yeah, plus and C squared.
C squared minus 2 times the product of the letters you just put there.
Shouldn't it be minus C squared?
Nope.
No?
No.
Minus C squared.
So what would go right there?
2
AC.
AC times the cosine of the angle across from the letter you started with.
Beta.
Yep. And we could write it a third way if you want to start with A squared or X squared or whatever letter you want to use, just follow the pattern. Okay. What's going to go right here?
B squared plus C squared minus 2BC times cosine alpha.
So writing it with specific letters, that's not important. What's important is the pattern. One side squared equals the sum of the other two, whatever you want to call them, minus twice the product of the other two, times the cosine of the angle across from the one you started with. That's what you want to remember.
So it looks really complicated.
It looks really, it's not that complicated. But let's see what happens if you tried to use the law of cosines where you knew you had a right triangle. Like, let's do it knowing that gamma was 90. Let's just fill in a 90 for gamma and see what happens. Because you can use this on a right triangle. But watch what happens. The cosine of 90 is 0. And what's 0 times anything? 0. So effectively what happens is if you try to use the law of cosines on a problem where you know the angle is already 90, this last part just disappears. And you're left with exactly the Pythagorean theorem.
That's cool.
Okay. This is like an adjustment. If the angle is not 90, then this part will not be 0, and then it will make a difference. And it is, again, it is not that hard to prove why that is that. It just probably take about 10 minutes, but not something we're going to go through today. But that's it. That's the law of cosines. So there's two types of problems that we can solve with law of cosines. In type 1, you're going to be solving for a side and an angle. You're going to have to do both to finish this off. In type 2, you're always solving for an angle. So type 2 is actually easier because you don't have to solve for a side and an angle, you just have to solve for angles. So we're going to start with type 1 because it kind of covers everything that happens. If you can do side angle side, you can do side side side. Let's try it. All right, so first of all, do we have a full row?
No.
No, then we need to forget about law of sines, which means we are automatically in one of these two cases. Is that side angle side or side side side?
Side angle side.
It's got to be side. It's not side 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 because you don't know all the sides. So you don't have a full row, and you don't have all the sides, so it's got to be side angle side. There's no other option. When you use law of cosines and you are trying to solve for something, you solve for the side first. Find, if it's side angle side, find the missing side. You have to do that first. So we need to find a version of the law of cosines that has C in it. Or actually, they all have C. Let me take that back. So there's a C in all of them. But we need to make use of the 42 degrees. That's the important thing. Which version here has a spot for me to plug in the 42? The first. So let's fill in everything we can into the first.
Oh. So you're always gonna, you want to find the one across from it.
You always want to find the side you're missing. Yep.
I see. So, okay, so you won't have to like rearrange it to solve for the one.
You're not going to have to rearrange anything. This is going to be more arithmetic than it is algebra. You're going to have a lot to simplify, but the variable is basically by itself in this type. So you get 4 squared plus 7 squared minus 2, 4, 7 times the cosine of 42.
Wait, and then you just solve it.
Now you just do that out.
Wait, so this is actually easier.
Well, yeah, I think this part doesn't really have any algebra other than just taking a square root at the end. Okay, so 4 squared gives me,
16,
and 7 squared,
49,
and 2 times 4
8,
times 7,
56.
56, cosine 42. Okay, well, what could we do next here?
Simplify all the
Add the 16. 49.
You can add the 16 and the 49, that's okay. And what would you get?
and so
65 minus 56. Okay, can we do 65 minus 56?
yeah. 5 would be good.
Well, could you do 65 minus 56 times 3?
Oh, no, never mind. Yeah, I forgot.
Yeah, you can't do this subtraction until you do the multiplication first. So let's handle the multiplication first. 56 cosine 42, and that's 41.616. Now you can do the subtraction. 65 minus what I had for my last answer is 23.384. Again, a lot of these steps I would probably combine together. I'm just trying to show every single step out for the first problem. And how would we get C by itself?
Square root of the answer.
Yep, square root of that answer. So 4.836. So there's your third side, 4.836. Now let's sketch this because I want to see what kind of triangle it is. I know what it was originally. Let's put A, alpha, B, beta, and there we go. It was side, angle, side. That was what it was originally. But now I know side C too, 4.836. Besides being side, angle, side, it's now 2 other types. Anybody see one other type that it is? Yeah?
Side, side, side.
It is also side, 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 which would mean we would continue on with law of cosines. And it's one other type.
Side.
Yeah, a couple ways you can look at it. Side, side, angle. Now these 2 types would be law of cosines. This type would be law of sines. But talk to me about the side, side angle case. with law of sines.
We don't usually want to use ones that we solved.
You wanna use
don't
ones
need to,
here?
right?
Well, you're going to have to use stuff you've solved for no matter what.
Okay.
Yeah.
I wasn't sure.
But there's something about the side-side angle case I don't really want to deal with. What can happen with side-side angle? The what? Yeah, we can get into the multiple solution or no solution. So we want to stay away from that. We started the problem with law of cosines. That's how we'll finish it. I'm not saying you couldn't do it a different way, but we'll finish up with law of cosines. Once you know all three sides, you know everything in every one of these formulas, right up to there. You know all of that information. So you can pick any version you want to find the angle you're missing. Let's do, we would want to pick either alpha or beta. Let's do alpha. Find cosine alpha. How does the version of the law of cosine start out that has alpha?
A squared,
Yep, a squared equals,
b squared plus c squared
yep,
minus 2bc times cosine alpha.
yep, and now fill all that in. So a squared, let's do some of it as we go. What's a squared? 16. What's b squared? 49. And don't take c and square it. You have c squared right above it. 23.384. So we already know that. Now I need 2 times b times c. I'm going to need someone with a calculator in a second. Let's start with 2 times b. What's 2 times 7? Now I need 14 times 4.836. 67.704. Next digit's lower than a 5.
It's just
Oh, because we rounded our answer anyway. Never mind. Yeah, okay, and then cosine alpha. Now, this problem is almost the opposite of the last one. This is more PEMDAS. Just follow your order of operations when you're doing arithmetic. This is solving an algebraic equation. We've got to get the variable by itself. So what would be the first thing we could do on the right-hand side to start to simplify this a little bit?
Like term.
Yeah, combine like terms. The only like terms you have are right there. What's 49 plus 23?
72.
72,384. If you're wondering, well, why didn't I subtract the 67 from that?
It's attached to the cosine.
It's attached to the cosine. It would be like if you had 16 equals 72 minus 67x. You're trying to get x by itself. You can't do 72 minus 67. You need to take the 72 and do something else with it. So what are we going to do with this 72? Subtract it from each side. Yep. And minus 72,384. For 16 minus 72, I'm going to need a calculator for that.
Negative 56.384.
Negative 56,384. Okay. And now what we have, if you want to think about it in terms of like an algebra 1 type of problem, is this. You have a number equals a number times something you don't know. How are you going to get your variable by itself?
divide by, in this case, the negative 67.
Divide by the negative 67. So divide by negative 67. Negative 67. Those are gone. Those are gone. And don't even worry about doing this out, because the more rounding you do, the worse it gets. So just leave it. 56,384 divided by 67,704. And how am I going to get my angle?
Inverse. Cosine.
Yep. inverse cosine of what's on the left and on the right. And the reason you don't have to worry about a second answer is because think about the other quadrant where cosine is positive. Quadrant 1. But what other quadrant is cosine positive? Yep. 4. The angles in quadrant 4 are between 270 and 360. Can I get an angle in a triangle between 270 and 360? No. That's why I don't need to worry about a second answer. But I do need to worry about a first answer.
Does that go for all love cosine problems?
Yeah. All law of cosine problems can never have two solutions. 56.384 divided by 67.704. Now, I mean, I can find a second answer to that. It's 360 minus that. And algebraically, it's an answer, but it wouldn't be in a triangle problem. So the answer here is 33.612. And now, I mean, we've already used things we've calculated to calculate other things, so at this point, we might as well just keep going with that. How can I get beta relatively quick? Yeah, and what's 33 and 42 add up to? 75.612. 104.388. And that's a law of cosines problem. Okay, that's probably the harder of the two types because you had to do one side, one where you had to find a side, and then one where you had to find an angle. When we look at this type, we're doing the same thing 3 times. Find an angle, find an angle, find an angle. And this is one of the only types that you can solve without using anything you've calculated, if you want to do the whole problem. Because you know every side, which means if you go back to these formulas, you can use any one of these formulas you want to start the problem. Because you know everything to the left of that line. So we could potentially find alpha, beta, and gamma completely separate. Let's see if we can do 2 of them. And then I'm just going to add together and subtract from 180 to get the third one. A little riskier because if you get one wrong, now you're going to mess gamma up. But it's fast. Okay, let's find alpha. So we've got a squared, b squared, c squared, 2bc, cosine alpha. Right, let's fill it in. What's a squared? So square it. And b squared? C squared? 2 times b. What's 2 times b? Actually, it's probably easier to do it this way. What's 2 times c? 10. What's 10 times 7? 70. And what's alpha? We don't know. Nice thing here is a lot of times the sides are usually integers, so arithmetic is a lot easier. Okay. What can I do on the right? Add the 49 and the 25, which gives me 74. Okay, next step. Bring the 74 over. That's gone. What's 81 minus 74? 7 equals negative 70 cosine alpha.
Wait, no, it's not 6. No, I'm stupid. Never mind.
Well, 80 minus 74.
Sorry, I'm sorry.
And then, how are we going to get the negative 70 over? Divide by it. And how are you going to get rid of cosine at the same time? So you really can shorten up the amount of steps you have to write down if you do combine. So it's the inverse cosine of, yeah, it's negative what? What's that? 1/10. So negative 70.
Wait, sorry, how did we switch around the 7 so we had
95.739.
divide 7?
So we divided by negative
Yeah.
70
I get it.
and then took inverse cosine. And that's it for alpha. Now, do the same thing again. Either beta or gamma. Let's do gamma. Okay, what's my law of cosines that has gamma in it?
C squared.
Minus 2.
What goes on the end?
Times cosine.
Gamma. Okay, just so I don't have to scroll up and down. What's c squared?
25.
A squared?
81.
B squared?
49.
All right, and then what's A? 9. So 2 times 9 is 18. What's B?
7.
What's 18 times 7?
70 plus 56 and then it's 126.
126.
It is 126.
Okay. Cosine gamma. All right. What's 81 and 49?
130.
Yeah. I think that adds up to 130. Cosine gamma. Okay. What would be my next step?
Subtract 130.
Subtract the 130. Okay, 25 minus 130,
Negative 105.
negative 105. So what are you gonna do with that negative 126? Divide it. So negative 105. So might as well just cross the negatives out. And you also need the inverse cosine. And let's see what we get. Inverse cosine 105 over 126. 33.557. Not sure. There you go. Now, find beta the same way if you want, or if you're really confident that alpha and gamma are right, just add them up and subtract
They're,
from 180.
they're definitely right.
All right, now let's just add them up and subtract from 180. So 180 minus 95.739 plus 33.557. 50.704. Okay, that's pretty much the basics of what you can do with law of cosines. And so I'm going to change the homework a little bit, but I'll put that up right now. We didn't quite finish 8.2. There's one more thing in it about finding the area of a triangle based on the law of cosines. That's pretty easy, but we'll do it next time. Okay, so that's the homework for tonight.